Hello, and welcome to Calgebra video 1.1 for Algebra 1 on solving simple equations. When we talk about solving an equation, we mean finding any and all solutions to the equation. Typically, this means one solution, but a lot of the times we will see that there could be more than one solution. There could be no solution, or there could actually be an infinite number of solutions. So solving the equation means figuring out which one of those it is, and then finding any and all values that there are. And solutions are values that make the equation true. So that's what allows us to have either multiple or no solutions as well, because sometimes lots of things make the equation true, sometimes nothing makes the equation true. In order to solve an equation algebraically, we use inverse operations to form equivalent equations that have the same solutions. We've highlighted here some of our inverse operations. Addition and subtraction are inverse operations, and multiplication and division are inverse operations. There are others, but we're going to focus on those four for now, the basic four operations. And just as a warning, don't use zero. Using zero with addition or subtraction won't make a difference. It won't change anything, so it doesn't really make us make any progress for us. And with multiplication and division, if we use zero there, then we actually can, in a sense, destroy the equation, making it no longer valid. So, when you're solving an equation, leave zero out of it. All right, let's see some examples. Here are four one-step equations that will show us how to use inverse operations in order to solve an equation. My first equation is x minus 5 equals 15. Here I have a subtraction. In order to get rid of the subtraction, I'm going to use the inverse operation of addition by adding 5 to each side of my equation. This 5 is on the left side of the equal sign. This 5 is on the right side of the equal sign. I got to make sure that I'm balancing the equation that way. When that happens, this minus 5 and plus 5 are basically canceling out, leaving me with just x on that side of the equation. Keep my equal sign, and then I combine the like terms on the right. 15 plus 5 gives me 20, and that's my solution. You could plug in to check that 20 makes my original equation true. 20 minus 5 equals 15, and that is true. So that little check shows that I've done it correctly. I used addition there to solve that equation. Moving over to the right, I have 6 plus h equals negative 2. I want to get that h by itself, and I have an addition. And so in order to get rid of that addition, I'm going to subtract the 6. And I'm going to do that on each side. And so again, we're trying to get things to cancel out, allow the variable to be by itself. So the 6 minus 6 is gone, leaves just an h. And on the right side, I have negative 2 minus 6. A negative minus something is going to end up being a bigger negative, so that's going to be negative 8. And that's going to be my final answer there. Once again, go back in to check. 6 plus negative 8 basically becomes 6 minus 8, which is going to be negative 2. All right, third equation, b divided by 5 equals 7. Now, you might have also seen a problem that looks like this. b over 5 equals 7. These two are exactly the same problem. They're both indicating division. We have divided by 5 and over 5 both mean the same thing. So the inverse operation of division is multiplication. So I'm going to multiply each side by 5. And when I do that, divided by 5 and times 5 cancel out. They undo each other. Leaves me with b equals 7 times 5, which is 35. And then the check is pretty obvious. Just 35 divided by 5 is 7, and that's true. I guess if I had seen it as the fraction, I might have multiplied by 5 like this, and that would have shown that these two would have canceled, and that still would have led to b equals 35. All right, last example on this page, we've got 9n equals 3. Remember that 9 N means 9 times n. A number next to a variable is called a coefficient, and I want to divide by that. So you can either use the division symbol, or oftentimes we just use a fraction bar as well. Either way would be fine. Now we get, oops, cancel those out first. That's what's happening there. I'm going to end up with n equals, now 3/9 is a fraction, but it can be reduced all the way down to 1/3. So you either want to leave it like that, or as a decimal, that's 0.3 repeating. Don't say that it's approximately 0.33 unless the problem tells you to round. In this case, we want to keep our answer as exact as possible. So there you go. There are 4 one-step equations that you solve using inverse operations. Alright, let's look at a word problem here that we can solve in the same manner. Mr. Callan drives 30 miles to Algonquin every morning. His drive takes about 45 minutes. What is his average speed? Now typically, a problem like this would require us to use the relationship we probably know pretty well. Distance equals rate times time. Very common relationship that we have to use here. And so let's take a look at filling in this equation. Distance we know is going to be the 30 miles that Mr. Callan travels. Rate is our unknown. That's what we're going to know. We know speed, rate, anything like that. So I'm going to call that S for speed. Now the time. What we have there is we're told the time takes 45 minutes, but usually we're talking about for speed when we're driving miles per hour. So since 30 is measured in miles, I'd like to put the 45 minutes in terms of hours. And 45 minutes we know is 3/4 of an hour. I'm going to put that in parentheses or next to dot. I know the formula has the x for multiplication and it's fine there, but when we're doing the math out, we want to avoid using the x because that often stands for the variable. So now in order to solve for the s, I have a multiplication that I need to get rid of, so I'm going to divide each side by 3/4. Doing that will cancel out these two fractions here, and I have to think about what does it mean to actually divide a number by a fraction. Well, remember that dividing by a fraction means multiplying by the reciprocal. And so 30 divided by 3/4 becomes 30 times 4/3. What might make that easier to multiply is to put the 30 over 1, and then you're multiplying numerators, multiplying denominators. 30 times 4 is 120. 1 times 3 is 3. And so then we could actually just reduce that. 120 over 3 ends up being 40 over 1, or just 40. And then we put the label on it of miles per hour. We want to make sure that we put the proper label on it and ask ourselves if that makes sense. Is that a reasonable speed that Mr. Callan could travel at on average? Absolutely. And I can guarantee you he's always right at the speed limit, never exceeding it, because that would be illegal. All right, I hope this helps make some sense, and now you feel more comfortable solving equations going forward.